All right, so for our notes today is going to be the mid-segment triangles. So when we have a mid-segment, what that is a line segment connecting the midpoints of any two sides of, in this situation, a triangle. So later on you can hear about mid-segments of trapezoids, etc., but we're focusing on the triangles right now. So a line segment connecting the midpoints of any two sides of a triangle. So basically, AKA, it bisects two sides. So we have over here, midpoint to this side, midpoint to this side, line segment, so thus it is the mid-segment. So you can see this would be the three common ways that you would technically see a mid-segment in any one triangle. So the second bit of important information when it comes to mid-segments is that it is a line that is parallel to the third side. So it has all the angles formed by parallel and transversal lines. So it is parallel. I'm going to scoot this up a little bit here. So it is parallel, and since it's parallel, you might see things like corresponding angles would apply, because technically this becomes a transversal between parallel lines. This is a transversal between parallel lines, and there you go. You might also have something that looks kind of like this, where maybe it is here's one mid-segment and maybe another mid-segment. But either way, this is a transversal line cutting between parallel lines, so you have alternate interior angle rule apply as well. Also, you could imply something or get something along the lines of linear pairs or supplementary. So those angle rules still apply, including even triangle sum theorem. That if you notice, this triangle here and this triangle here still applies. So that can help with finding angles within a triangle given the mid-segments. Alright, so I'm going to scoot it up. Okay, so the third bit of information is that half the length, the mid-segment is half the length of the third side, or the third side is twice as long. So it's just the way it happens to be, since it's in the middle and it's the line segment, that this line down here and this line here end up being the exact same. Or basically AD, all of AD, is twice as long as BC, or vice versa. BC is half the length of AD. So you can use this to find any bits of these information. If I know what AD is, I can cut it in half to find BC. If I find BC, I can double it to find AD. And or if I know AD, I can cut it in half to find ED or AE, given that this is a midpoint in this situation here. So this comes in handy quite a bit when solving problems in the mathematics. All right, so let's go ahead and scoot this up. All right, last but not least, number 4, when it comes to mid-segments, there are 3 mid-segments in every triangle, and those 3 mid-segments break it into actually 4 congruent triangles. So you'll see here that this is a one line, and we end up with 1 tick, 2 tick, 3 tick, etc., 1, 2, 3, and 1, 2, 3. So this can also help you find measurements when it comes, and even angles, because that will still apply, that if this angle here between 3 and 1 is going to be congruent to any other angle that is between 3 and 1. So since they're congruent, all of our corresponding parts of triangles, of congruent triangles are congruent theorem will also apply to our triangles. All right. Well, those are the 4 main significant bits of information to know about midsegments and triangles. I hope this helped.